Hi, I'm Linda from English Learning Mind Map. Today, we will learn about deep space exploration. Deep space exploration. To transcend boundaries and pioneer frontiers through deep space exploration, we must build better engines. Basically, we are trying to go further into the stars than ever before. Extraterrestrial colonization. As a core pillar of deep space exploration, extraterrestrial colonization allows us to establish outposts and sustain life on other worlds. In simple terms, we are making a plan to move people to the Moon or Mars permanently. Habitat pressurization. Habitat pressurization is a specialized branch of extraterrestrial colonization used to maintain equilibrium and shield occupants from the vacuum of space. This means building strong bubbles where we can breathe without a helmet. Atmospheric regulation. Within the scope of habitat pressurization, we use atmospheric regulation to recycle oxygen and filter toxins from the air. In other words, we are using machines to keep the air fresh so the astronauts don't get sick. In-Situ resource utilization. In-Situ resource utilization serves as a practical application of extraterrestrial colonization to extract minerals and generate propellant from alien soil. Essentially, we are living off the land, so we don't have to carry everything from Earth. Lunar mining. Under the umbrella of in-situ resource utilization, lunar mining helps to harvest ice and process regolith into building materials. To put it simply, we are digging up moon ice to make water and fuel for our ships. Autonomous robotics. Autonomous robotics is an essential component of deep space exploration designed to navigate terrain and transmit telemetry from dangerous places. Simply put, we send smart robots to explore where it is too risky for humans. Unmanned probes. Unmanned probes are a functional layer of autonomous robotics used to photograph celestial bodies and analyze composition from a distance. This means sending small cameras on rockets to fly past planets and take pictures. Deep space interceptors. To enhance unmanned probes, we build deep space interceptors to track asteroids and rendezvous with comets. At its core, we are making very fast robots that can catch up with flying space rocks to see what they are made of. Swarm intelligence. Swarm intelligence is a vital aspect of autonomous robotics used to coordinate units and maximize coverage of a search area. Basically, we use a whole cloud of tiny robots that talk to each other to explore a planet faster. Cooperative mapping. Under the umbrella of swarm intelligence, cooperative mapping helps to scan surfaces and build 3D models of alien caves. In short, all the little robots work together to make one big, perfect map of the ground. Orbital logistics. Orbital logistics is a critical requirement for deep space exploration to streamline launches and lower costs for every mission. Effectively, we are organizing our space trips so they aren't so expensive and messy. Payload optimization. Payload optimization is a strategic part of orbital logistics used to maximize capacity and reduce weight in the rocket's nose. This means packing our bags very carefully so the rocket doesn't have to work too hard to get to space. Reusable rocketry. A specific tool within payload optimization is reusable rocketry, which works to land boosters and refurbish engines for the next trip. To put it simply, we are building rockets that land like a helicopter so we can use them again and again. Space debris mitigation. Space debris mitigation is a vital element of orbital logistics used to track junk and prevent collisions in the crowded sky. Basically, we are making sure that old pieces of trash don't crash into our expensive new spaceships. Orbital cleanup. Within space debris mitigation, orbital cleanup helps to capture fragments and deorbit trash so it burns up safely. In other words, we are acting like space garbage men to keep the paths around Earth clean. Astrobiological research. Astrobiological research is the final branch of deep space exploration intended to seek life and unravel mysteries of our origins. Effectively, we are trying to answer the big question, are we alone in the universe? Biosignature detection. Biosignature detection is a key part of astrobiological research used to identify molecules and verify organisms on distant moons. In simple terms, we are looking for chemicals that only come from living things. Spectroscopic analysis. To improve biosignature detection, we use spectroscopic analysis to scan light and decode atmospheres of faraway planets. At its core, we look at the colors in a planet's air to see if there is oxygen for things to breathe. Exoplanet characterization. Exoplanet characterization is a vital aspect of astrobiological research used to classify worlds and measure distances to other suns. Basically, we are trying to find planets that look like Earth in other parts of the galaxy. Habitability assessment. Under exoplanet characterization, habitability assessment helps to judge climate and find liquid water on the surface. In short, we are checking if a planet has the right temperature for a swimming pool, which means life could be there. Thanks for watching. Please like and subscribe for more English lessons.